why do we need TensorFlow? You see, TensorFlow is actually an open source machine learning framework to carry out high performance numeric computing. It provides excellent architecture support which allows easy development of computations across a variety of platforms ranging from desktop to clusters of servers, mobiles, and edge devices. Now you might be wondering why TensorFlow and how it becomes so popular in such a short span of time, right? And what makes TensorFlow so special that we see a huge surge of developers and researchers opting for TensorFlow framework? Well, you see, when it comes to artificial intelligence framework showdown, you'll find TensorFlow emerges as a clear winner most of the time. The majority of credit goes to soaring popularity and contribution across various forms such as GitHub, Stack Overflow, and Quora. The fact is, TensorFlow is being used over 600 open source repositories, showing its roots in many real-world research projects and applications. And coming to the features that I would like to mention is that TensorFlow is supported for different languages. This allows developers to integrate TensorFlow in unique way. As we know, TensorFlow was developed by Google, which itself makes it a state-of-the-art. But a point to be noted is that it has well-written and easy to understand documentation even for the beginners. Most of the tech giants like Google, Coca-Cola, Instagram, and General Electric and many more use TensorFlow in their deep learning and machine learning model, thus making it an industry standard and hence must-have skill for a relevant job role. So now, what is TensorFlow? Well, TensorFlow is an open source end-to-end platform for creating machine learning applications. It is a systematic math library that uses data flow and differentiable programming to perform various tasks focused on training and interface for deep neural network. It allows developers to create machine learning applications using various tools, libraries, and community resources. As mentioned earlier, currently the most famous deep learning library in the world is Google's TensorFlow. Google makes sure to use this TensorFlow in its machine learning product in order to enhance its use. For example, it uses TensorFlow in search engine, translation, image captioning, or even recommendation engine. To give you a concrete example, Google users experience a faster and more refined search with AI. If the users typed a keyword in a search bar, Google provides a recommendation about what the next word could be. Unlike other framework, I would like to say TensorFlow as an ecosystem. And the building blocks of TensorFlow ecosystem is nothing but a tensor. So now you might be wondering, what's a tensor, right? Well, you see, tensor is nothing but a multi-dimensional array. Tensor can have a shape and a data type, but do not have actual values. And honestly speaking, TensorFlow over here makes use of this shape. Even though the value is scalar, that is nothing but, if you have a value like 22, it is also represented as 1 cross 1 array. No matter be it a single dimension array or an n dimension array, everything over here is referred to as a tensor. Now you might be wondering, hey Junaid, you said TensorFlow is an ecosystem. So how does it work? Well, you see, the way TensorFlow works is on something called as computation graph. So what is this computation graph, right? Computation graph is defined as directed graph where nodes corresponds to a mathematical equation. Computational graphs are the ways of expressing and evaluating mathematical equation. So let me now quickly move to my canvas and show you how computational graph works. To give you a better example of what is computational graph, let me just quickly take an equation over here. Let's say this equation over here represents p is equal to x plus y. So this is basically a simple mathematical equation. So now how would I put this in a computational graph? So as I mentioned earlier, over here the node represents an operation. So this part over here is referred to as node, and the operation which this is going to represent is positive or plus or the addition operation. So the inputs for this is going to be x and y, and then we have an output over here p, which is nothing but p is equal to x plus y. So this is what a computation graph represents. So to give you a better understanding of why we use computational graph, that's because of something called as forward propagation and a backward propagation. So to understand this, let me take up a bit complex equation. Let's say we have something like g is equal to, then we have, let's say we have an operation here x plus y, and then this would be product times z. So if I have to put this in a computational graph, first off we'll have this node, right? So let's go by BODMAS rule. So it will be brackets. So obviously we'll put the brackets over here, and operation within this is positive or plus, and then we'll give this as x and y. And the output of this is p. And this p over here represents x plus y. And we have to add another node, right? That's because we have a multiplication to be done here. So let me add one more node over here, which would represent product of two numbers, and I would just pass an arrow and one more input, that's nothing but z. This is gonna be g, right? And this output over here represents p times z, right? So let me quickly erase this. So this is gonna be p times z, or I can just write as pz, right? So I'm pretty sure this is something which is crystal clear to all. And the output, if I give over here, this is gonna be p times z, and here p represents x plus y. So let me quickly write that as well. X plus y times z. Whatever we did now is referred to as forward propagation. And what happens in the forward propagation is we are trying to find the value of g. But when we are dealing with deep neural network, as I have mentioned earlier, we use TensorFlow to create or to work with neural networks or deep learning. And we all know deep learning is completely based on neural networks. Or I can also say it as it is inspired by artificial neural networks. So now what I'm going to do over here is the other most important thing when it comes to deep learning is something called as updating the value of weights. So how do you update the value of weights? It's obviously by backpropagation. And the way backpropagation works is by taking a partial derivative. So to give you a better understanding, let me just take this particular example here. Let me quickly erase the rest of the stuff. So let us now take or assign the value for our x, y, and z. Let's say x over here represents a value x is equal to 5. And at the same time, we have y is equal to 10. And let's take the value of z over here as, let's take it as 1. Okay, let's take it as like 2, right? So 1, like product times 1 is nothing but the same number. So just to differentiate, let's give it as 2. So now if I'm trying to move this towards forward propagation, what's going to happen is I'm supposed to find like it would follow the same map. So now the value of x over here would be 5, y here would be 10, and z over here would be 2. So this is the initial value. So now let's see what happens in the forward propagation. So now x and y get added up. So this would be 15, and this would be represented over here as 15. And now, as you can see here, we are supposed to perform the product. So this is nothing but product between p and z. 15 times 2 is what? 30, right? And so finally, the value of g over here is nothing but 30. Let me now show you what backpropagation is. With backpropagation, what's going to happen is we are going to change or we are going to update the value of these x, y, and z. If you don't believe me, let me quickly show you how that works. So first off, what we'll do is we're going to take the differentiation. So this is going to be like a partial derivative. So first off, we're going to start over here. We're going to start over here by saying it as delta g by delta g, which is nothing but, what do you say? What do you think delta g by delta g is? This is nothing but 1. And then finally coming down over here, we have to take partial derivative with respect to this. So let me quickly show you. So partial derivative of this with respect to p and with respect to z. So let's take this. Let me quickly write this down here. So first off, we take partial derivative of g, and this should be 1. And next we have pz. We are moving in a backward direction. So obviously we'll be moving from right to the left. So let me quickly do partial derivative over here. In a stage 2, we'll have pz. So pz, partial derivative of this by with respect to p, which is nothing but z. And the value of z is what? 2. And then similarly, we are going to do partial derivative of pz by z. So partial derivative of this, I hope you know what is derivation. So obviously this would end up being p, and the value of p over here is 30. So the value of p over here, what did we get? It's 30. So this is going to be 30 here. So where does this value 30 represent? This is the place where I'm performing the partial derivative. So if you have confusions from where am I getting this, it's going to be here. I'm going to perform partial derivative over here. So this is going to be pz by partial derivative with respect to z. So this is going to be p. The value over here is going to be 30. I hope this is pretty much clear. And similarly, if I perform partial derivative here, so it's going to be pz by dou p, and this would give me z, and the value over here is going to be somewhere around 2, because that's the value of a z. So finally, we are supposed to come back to our third stage, that is nothing but the third layer. So in the third layer, we have x and y. So the way this is going to be is something like we have dou g by dou x and dou g by dou y, because we are trying to perform the partial derivative of g. So the way this is going to look like is dou g by dou x. First we'll do it for x and then we'll go on for y. And the way this would look like is, I'm supposed to perform something called as chain rule, because now x is not directly related to g. If you can see here, the x part is not directly related to g. So let me quickly take another color and show you. So if you can see here, x is not directly related to g. X is related to g via p. And the same thing goes with y. So this is why we'll be performing chain rule over here. And the way chain rule works is, this is something going to be something like this. So this dou g would remain the same. And then as it's via p, right? So it's going to be dou p times, this is going to be dou x by dou x. So let me quickly erase this and write it properly. So this is going to be dou p by dou x. Similarly, let's do it for y. So if it is dou g by dou y, this is going to be dou g by dou p times dou p by dou y. So let's see what does this represents. So we know what is dou g by dou p. So dou g by dou p over here. So now what's going to happen over here is, I hope you understand why we are using this part over here. So let me just quickly highlight this. And this part over here, and this part over here, and this part over here. This is nothing but part of a chain rule, because these people are dependent upon p, x and y are dependent upon p in order to be related to g. Let's quickly see what happens. Let me take another color here. So as p and x have a direct relationship, what's going to happen is this px is going to be replaced by 1, and the same thing goes over here. We already know the value of dou g by dou p. I'm pretty sure you might be wondering, where did we calculate this on the graph over here? Well, if you look close, this pz over here is nothing but g. This pz over here is nothing but g, because after computation we are getting this, and p here refers to x comma y. So what I'm trying to say here is p. So this is pz. So now what's going to happen is, we will try to form now delta g by delta p. And what is the value of this? So if you remember this, what would be the value of dou g by dou p? You can refer to this part over here, because this is represent the same thing. So this is nothing but dou g by dou p, which is nothing but z, which in turn is 2. Let me quickly erase this z just to avoid the confusion. So this is how we get dou g by dou p, and the value of this is 2. So let me quickly fix that. So this is going to be 2, and the same thing over here. And this is going to be 2 times 1, same thing over here, 2 times 1. And now this is going to be 2 and 2. So what change did we see here? First off, let's see what is the initial values. So initial value over here is nothing but 5, 10, and 2. So these were the initial values. So what are the new values over here that we have? Well, if you can see close, they all have updated. The value of z now is nothing but 30. And the value of x and y has changed from 5 to all the way down to 2. So let me quickly update that, and y is equal to 2. And this is exactly how backpropagation work, and this is how the weights get updated when we are trying to perform artificial neural network, or when you try to perform backpropagation during any of the deep learning process. I hope now you understood why you're using this computational graph. So now that you know what is TensorFlow and why we need it, let me quickly show you a tool, or I can also say it as a fun pastime, to understand how neural network works. And this is something which is written in JavaScript, and this is called as TensorFlow Playground. So what is this TensorFlow Playground? Well, you see, TensorFlow Playground is an interactive visualization of neural networks written in a TypeScript using D3 JavaScript. It contains a tiny neural network library that meets the demand of educational visualization. You can simulate real time in your browser with small neural network and see the results instantaneously. So let me quickly move to my browser and show you how this TensorFlow Playground looks like. Well, as you can see here, we have some kind of interface, or you can say some kind of table over here which represents something over here. Well, let me quickly show you how and what would this look like. So over here, this x1 and x2, these are nothing but the inputs. And these are nothing but the neurons. And this is nothing but the output neuron. Let's say we are trying to perform a classification task here. Classification, if you know, it's nothing but, whether it's yes or no. We have two outputs. Either it's there or it's not there. So we are going to pass some learning rate. You can give any value. Let it be like this thing. And then activation, you can use any of these. I'll be using ReLU. And then we can also use regularization, but as of now, it's not needed. Then yeah, learning rate. And then we can perform, we have a couple of options here. We can perform classification or regression task. So if I am taking this regression task, let me quickly execute this. So you'll see here that a beautiful line is being drawn over here. And this part over here represents one cluster and this part over here represents the other cluster. So let me quickly increase this neuron and let me add a couple of layers. I'm just randomly using this. I'm just randomly trying to play around over here. So let me see, let's increase some noise and also have some batch size increased and the ratio of training to test data. Let me keep it somewhere like this and let me execute this now. So as you can see here, we have some kind of regression task which has been happening and this is going to run. But the important thing over here to consider is the way it is classifying over here. So there's a thin border line which is being performed and this part over here represents one thing and the other one over here. So now that you know what is TensorBoard and you know how neural network works from within, we have also seen the visualization. So now let us get started off with installation of TensorFlow. So installation of TensorFlow is pretty simple. All you need to do is open up your Anaconda virtual environment and install TensorFlow there. So let me quickly show you how that works. So over here, I'm here down to my Anaconda prompt. So what I'm going to do is let me activate my environment, or we can also create our environment. So I've already created it. So let me activate it. So it's going to be conda activate TensorFlow. So in order to install TensorFlow, you have to just perform a simple step that is nothing but type pip install TensorFlow. So once you hit this, just hit enter. So you'll see that it would take some time to install TensorFlow package on your system. Alright guys, as you can see here, we have successfully installed TensorFlow 2.0. So in order to see whether we have installed it or not, let me open up a Python shell here. So for that, Python, and let me quickly import TensorFlow. The reason why I'm getting this error is because I don't have GPU installed, but TensorFlow is working when it comes to the CPU version of it. So this is exactly how this would work. But most of the time what happens is people don't have a high-end laptop. In order to train a deep learning model or in order to use TensorFlow on your system, you're supposed to use something like a high-end GPU, which can be a bit expensive because you cannot run TensorFlow GPU on any graphic cards. So in order to overcome this, what I'm going to do is we are going to mostly work on Google Colab. So now that we have installed TensorFlow on our system, but as I mentioned earlier, we won't be using our inbuilt IDE or our system IDE in order to run or in order to use TensorFlow. We'll be using something called as Google Colab, which is nothing but a Jupyter notebook-like system which is provided by Google. So let me quickly jump to my code editor, that is Google Colab, and show you the basics of TensorFlow. So the first thing that we are going to do over here is we're going to import TensorFlow. So to do that, all we need to do is import TensorFlow as TF, and then we'll execute it. So to execute this, I'll be clicking Shift Enter. So if you remember, sometime back I told you this TensorFlow, I consider it to be an ecosystem. So now you'll understand why I call it an ecosystem. See, usually when I try to perform, like when I give a variable, so it's going to be something like 5, and then I have another variable over here. This is going to be like 10. And finally, let's say if I want to perform this operation, it's going to be C is equal to A plus B. And I get an output over here, which is nothing but it's going to be 15. So this is how convention way it works. But this is not the case in TensorFlow. So the way it works in TensorFlow is if you want to have a constant or variable, you're supposed to define it. So it's going to be TF. So this is nothing but a constant. So constant, or I can also say it as variable. And now what we're going to do is we're going to pass the value. So the value that I'm going to pass over here, let's say it as 5. And we're also supposed to give a data type. So this is nothing but we have d type, and we can use it as tf.int 32. So similarly, what I can do is let me copy this. Let me have something down for b here, and let's give the value over here as 10. And let me quickly execute this part. So now as you can see here, so now if I want to perform addition over here, what I'm going to do is I'm going to have c, which is nothing but a variable. So for this it will be tf, which stands for TensorFlow.add a comma b. So now if I see this, you will see that we will get a value over here, which is a numpy, and it gives 15. Similarly, let me see if I can create an array here. So we have this array, and within this, let's take some random values. So let it be like 3, 3, 4. Some random values, it has no order here. And similarly, let's create an array here. Let's give it as 9, 8, 7. And now let me execute this. So the output over here is going to be an array wherein it's going to be 12, 12, and 13. And the shape, it also gives us the shape of an array. Now, if you want to convert this into numpy, all you need to do is dot numpy and just give it a function. So you'll see that we get this in the form of a numpy array. This is the very basics of how and what is TensorFlow. We are trying to assign a variable here. And now another thing that TensorFlow also provides us with condition statement as well as the if loop or for loop. So let me quickly show you how an if condition would look like. Or let me give it as conditional statements. So what is this if conditional statement? Conditional statement is nothing like if a is equal to 5 and b is equal to 10. And now usually what I would be doing is if a is greater than b, then print a. And then I also have else condition, else print b. So now whichever is higher, I get that value. So let me put 15 here. So we'll see the value now changes to 15. Similarly, we can perform the same kind of operations using a TensorFlow. So let me take an example of a itself. So first off, what we're going to do is we're going to have a constant. So tf dot constant. And now what I'm going to do is let's take some constant value like 10. And then we'll have b is equal to tf dot constant. Let's say 20. So in general, what we'll be doing is we'll put if a greater than b or less than b. So that's not how it works here. The way it's going to work over here is first off, we'll have a variable. And in order to perform any comparison or any condition, we have this built-in function called as condition. So it's tf dot condition, cond. And now within this condition, it takes up 3 parameters. The first parameter is going to be the condition. So for that, what we can do is we can perform any operator. You have greater than, equal to, less than, equal to, not equal to. So similarly, we can have tf dot various kind of operations such as like greater than, less than. So let's take less. You can see here we have less than, equal to, greater than, equal to. So, and this is a function again. And what this is going to take is this is going to take a and b. I hope you understand this. And now it's going to take another parameter. And what we're going to pass over here is nothing but the function. We haven't created this function yet. Let's say we have functions f1 and f2. So now the way I want this condition statement to be is like, if a is greater, print a. If b is greater, print b. So in short, what I would say is, if a is greater than b, print f1, else print f2. Or over here, it's going to be if a is less than b, print f1, else print f2. So this f1, f2 over here is nothing but the function. We cannot just pass the values. So in order to do that, all we need to do is we need to define a function. So def f1. As is the function, this has to return tf dot constant a. And similarly, we're going to do it for function f2. So let me just copy this and print it down here. So let me execute this. So now we have a and b. As you can see, a is obviously less than b, so it's gonna print a. So let's see what it gets. So we have r dot numpy, and let's execute this. You can see here we have 10. Now if I change the value of 10 over here to 100, we are gonna get the output here as 20 because it's gonna be 20. So this is how we can perform if condition or conditional operation. Similarly, we can also perform our looping statements here. So let me quickly show you how that works. So first off, what we're going to do is we want something like, an array wherein we want to print numbers like from 1, 2, 3, 4, 5 to 10. So first off, unlike the normal way wherein we can append to the list, what we're going to do is first off, we are going to create an array. I hope you understand what is an array. array is nothing but it's a fixed size and we cannot change it. So it's going to be tf.variable. This will have nothing but zeros. So let me quickly import my numpy. So it'd be np import numpy as np. And now what's going to happen is we need zeros. So I'll just use np.zeros. And I need like 10 whose integer or data type is nothing but np.int32. So this is one numpy array and let me execute this here. So now what I'm going to do is I'm going to create a function. So def run and let me just give here. So I'll have I. So this is tf.constant because we obviously need like some value to close our while. So obviously this I will start from 0 and the data type of this I is going to be int. So d type is nothing but tf.int32. So now let's see, we have while loop tf. As I mentioned earlier, in order to perform any operations, we have a lot of built-in libraries. So if you want less than, greater than, all you need to do is tf.less or less than equal to, whichever suits you. And then we'll give a number here, less than or equal to 10. But obviously this value has to be compared. So we'll give it here as I. As long as I is less than and equal to 10, it will continue to run. So now what I'm going to do is we have this result of I. So this is I is nothing but the index, and then we'll assign this value. And the value that I'm going to assign is nothing but the value I. And now what I'm going to do is we obviously have to increase the index value. So as this is a constant, it will not change. So I plus equal to 1. So now let us call our function here. So to call a function, we'll have run, and this would return us a while loop. So let me quickly execute this. So we are getting this error. It says index 10 of dimension 10 out of bound. It should be pretty simple. Let's see where we are going wrong. The reason why we are going wrong over here is because we have defined here as 10, but it should be 11. Or we can just change it to less than and not equal to. So it would work properly fine, but it's okay. We changed it there. So now let's print out this result. So what I'm expecting is initially the result was nothing but 0, 0, 0, like 11 zeros. And now we'll be having zeros something like 0 to 11 or 0 to 10. Okay, let me quickly run this from the start. Okay, so let me just enter here. All right, so now what we are expecting here is when we had this result, it was nothing but like 11 zeros. But now as we have inserted the value of I and also incremented it, so what I'm expecting here is it's going to be like 0 to 10. So let's print this. So let's print our result. So result. If I just print out result, we will get this in the form of a TensorFlow. We can still see it's a numpy array. So we have it from all the way from 0 to 10. But now if you, by any chance, if you want this in numpy array, so all you can do is numpy, and then this would give you a numpy array here. These were the very basics, or I should say tip of the iceberg when you're dealing with TensorFlow. It's very simple. You can always refer to the documentation of TensorFlow to get a better or best understanding of how it works. So moving ahead, let us now see how we can implement TensorFlow in a simple artificial neural network. So what I'm going to do over here is I'm going to use a built-in data set which is called as fashion amnest. And what I'm going to do is we are going to perform a classification task and we're going to use TensorFlow for it. So let me quickly jump to my code editor and show you how we can implement that. So same as before, I'm going to use Google Colab here. Let me quickly delete all of our tabs. So to start off, let's import a couple of libraries. First off, we would need NumPy. Then let's have something like matplotlib. And then we obviously need TensorFlow. And then we need our data set. So in order to get our data set, what I'm going to do is import TensorFlow dot keras dot dataset. So it's going to be from TensorFlow dot keras dot dataset. So let me quickly change this here. Or else we're supposed to write entire long sentence. So I don't want to do that. So import fashion amnest. Okay, so let me execute this. It has executed successfully. So now let us load our data set. So for this, it's going to be fashion amnest. dot load. Before I load our data set, let me quickly show you what this contains. It has images of 28x28 size, and then it has this 60,000 images. And the different classes that we have over here is t-shirt, pullover, hoodies, and the labels given to them, or I should say key value pair of this, is nothing but a list from 0 to 9. And what this would return us is list of tuples, so which would contain extrain and validation data. So let me quickly paste this over here. So now we have loaded our data. Let me quickly execute this. Perfect. So we have loaded our data and whatever it is. And now what we're going to do is, we obviously, before feeding this into our deep learning model, we obviously have to pre-process our data. So let me give here as pre-processing. To pre-process my data, what I'm going to do is I'm going to write a function here. Let me give the name here itself as pre-processing. This will take up arguments like x and y. And now what x is going to be is nothing but we are going to convert this into TensorFlow. So tf.cast. So what we want to convert x obviously, and then we want to convert or upcast this to float. So it's going to be tf.float 32-bit. And as we all know, we want to normalize our data. So to do that, all I'm going to do is I'm going to divide it by 255. And similarly, what I'm going to do for y is I'm going to convert this into integer. So it will be tf.cast. And we want the y value, and this I will be converting into integer. So int 64. And what this would return over here is x comma y. Similarly, what I'm going to do is we have to like pre-process this even more. So I'll create one more function, def create dataset. And what this is going to take is xs. I'll explain you what is xs in a while, ys, and then number of classes. So by default, it's going to be 10, because as you can see, we have 10 number of individual classes. And here ys, this is going to be tf.ones. So what I'm trying to do now here is I'm going to convert my y into a one hot vector. So let me convert that to one hot vector. So one hot, and obviously I'm going to pass my y here, and the depth, this is nothing but n classes. If you know how one hot vector works, you will understand why we need the depth. So it will be n classes. Perfect. So what this is going to return is, this is going to return as a data set, return tf.data. So I don't want the entire data to be in the form of an array. I want to slice it up. So to slice the data, what's going to happen is data set dot from tensor slices. And what I'm going to pass over here is xs comma ys. So let me execute this part here. So as I move here, now what I'm going to do is we'll create a training data set here, training data. So training data over here is going to be a create data set, and I'm going to pass here as x test and y test. So x train, and then we'll have y train. Similarly, we want to do it for our validation data. So validation data. So this is nothing but create data set. So xval, or this is going to be x test, and then y test. So let me execute this. So we are not having any error. So now what we're going to do is we are going to create a model. So we are going to use sequential model. So for this, all I'm going to do is I'm going to import our Keras library. So first off, let me have from TensorFlow dot Keras dot models import. Let me see what are the models that I need. First off, as I'm going to use sequential, so it's just going to be one. So sequential. We also need the layers. So from TensorFlow dot Keras dot layers. So what I'm going to import now is I need a reshape layer and a dense layer. So import reshape and then a dense layer. So let me execute this now. Perfect. So now what's going to happen is we're going to create a model. So it is going to be model is equal to Keras or dot sequential. So we have already imported sequential. It's going to be sequential. And now we are going to add the different list of layers. So now we are going to add different set of deep neural layers. So first off, we have Keras dot reshape. So we are going to do the reshape here. So the target shape over here is going to be 28,28. So it's not going to be 28,28, it's 28 times 28. So it's 28 times 28, comma, the whatever the value is there. And then the input shape over here. So we all know that 28,28 is the size of our image. So it's going to be 28,28, comma, whatever the number of images are. So I would like to give here as 1 because we are going to take one image at a time. Finally, we are going to add the layers. So Keras dense layers. So it's going to be dense. So what I'm going to do here is units. So number of dense layer you want. So let me give here as 36. And activation. The activation I'm going to use is Relu. Similarly, let's create a couple more. So all we need to do is we'll copy this here. And let me just give some increments here. So instead of 36, let it be 64. And finally, we have, let's give it here as 128. And finally, in our output layer, we'll have just 10 because we have 10 number of classes. And the activation that I'm going to use is softmax. So let me execute this. Fantastic. So we are not getting any error here. So let me also show you model.compile. So model.compile. So now what we're going to do is we're going to see model.summary. So it's going to be model.summary. And let me execute this over here. So here, as you can see, right, we have a couple of layers. So first off, we'll be having 728 and then 36, 64, 128, and then finally we have 10. The reason we have 10 is because the total number of classes we have is 10. So let's now compile our code. So to do that, we'll have model.compile. And now what a couple of parameters that I would pass here is optimizer. So the optimizer that I'm going to use is Adam. And then we obviously have to use the loss over here. So loss. So what I'm going to do is tf.losses.categorical cross entropy. So the loss I'm using here is categorical cross entropy. So this is going to be true. So finally we need to pass the metrics. So let's give the metrics here. So the metrics over here, we need the accuracy. So let me give it as ACC. So let me execute this. Now finally what we're going to do is we're going to train a model. So to train a model, we use model.fit. But what I'm going to do is, this returns as the history. So we'll give here his, and then we'll do model.fit. So what we're going to do is we're going to now pass our data set. We have our training data set. So we'll pass that. So let me quickly put this here in place. Let's see what are the different parameters this take. Let me quickly run this again. So this takes a couple of parameters. If you want me to execute this. So as you can see how it takes X, Y, and batch size and all. So let me quickly show you that. So what I'm going to do is, so this is going to be our data set here. And then we have to pass the number of epochs. So epochs. So we'll give it as like 10. And then steps per epochs. So even this will give it as 500 because the data set is pretty huge. Let me quickly close this here. We obviously need the validation split. So let me give here as validation split 0.2. And then finally, let me give here as valid. This should be fine. So before we execute, there's a small correction that I would like to make. This validation split over here doesn't hold good for this particular model. Instead of validation split, what I'm going to do is I'm going to pass the validation data itself. So let me quickly do some changes over here. So let me bring this down just to give a better appearance. And now what I'm going to do is I'm going to pass validation data. So this will be validation. This would be nothing but validata dot repeat. And then finally, we also have to give validation steps. So validation. So this would be 2. So let me quickly execute this or train our model here. Let's see how it looks like. So let me scroll down a bit. So yeah. So as you can see here, we have successfully trained our model. And we are getting this validation accuracy over here as 86%, which is pretty good. So now what we're going to do is, rather than getting our predictions now, let's see how our validation data, or let's graph these values over here. So we'll get this by his.history. So let's give a variable here which says something like h is equal to history. And now this is nothing but a dictionary. So let's see the key values over here. So we are not getting this key values. Let me see what's wrong over here. The reason why I'm getting this error is because it's supposed to be keys and not key. So these are nothing but the key value pairs, and each of these values is nothing but this value over here. So let me put these values in a graph and see how it's look like. So first off, we have to import matplotlib. So import matplotlib as pyplot. I think I've already imported this, but it's okay. So now what we're going to do is plt.plot. We'll be plotting the validation data. So validation, let's see what is the data we have. We'll be passing accuracy, and let me plot this first. At the same time, now we are going to plot validation accuracy. So plt.plot, and I'm going to pass here validation accuracy. And finally, we'll have plt.show. So let me execute this. So as you can see here, this is at one point where our accuracy has been increased. And after that, the accuracy has decreased. The reason why we're getting this graph shows that the model is overfitting. And in order to work this better, what we can do is we can perform early stopping. So let's do one thing. Let's train our model only till the 6th epoch. So let me just change from 10 to 6. If you want to execute this in a faster manner, what you can do is you can just change your runtime to GPU. What this would do is this would enhance or increase the speed of your every epoch that's happening here. So as you can see here, the validation accuracy is decreasing. So this is something very bad. The reason why we're getting this is because we're supposed to run this from the start. So what I'm going to do is let me change the runtime first, and I'll change the runtime to GPU, and let me save it. So what this will do is this will reallocate the memory, and we'll have to run this from the start. So let me run this now. So for me to run this, all I'm going to do is shift enter, shift enter. So I'm going to do this for every value here. Finally coming down to fit transform. So this is the place where our model is going to get trained. So as you can see here, now the execution is pretty fast compared to what it was before. So as you can see here, initially our validation accuracy was 85%, then it came down to 82%, and then it was 89%, which is good. And then finally it came down to 90 and then 87%. So what we're going to do is let's hit model.history, and then we have perform the same drills, and let's execute this. Before I execute this, let me give you the reason why we might have got this graph. As I was executing this model multiple times, maybe the model might have overfitted. So now we should get a proper graph. So as you can see here, although there is some overfitting happening, but we can fix that by having early stopping technique or something like that. So, but it's okay. This would work. So now what we're going to do is let's perform some prediction. So let's give prediction, and then we give model.fit. So model.fit. So here it's going to be model.predict, and we are going to do predict classes, and then we'll give here validation data. And let me execute this as of now. So now what this classes does is, we all know we have 10 classes here. It can be like shirt, pant, or whatever it is. And this is what it's supposed to do. And let's see how prediction would look like. So prediction, and let me execute this. So basically this is nothing but a numpy array. And now what I'm going to do is, so what we'll do is we'll take up some values here. We'll take up the values from prediction and the values from xtrain, xtest, and let's see whether we are getting a correct values or not. So let me quickly go there. So we'll have prediction. So we have predictions. So if I execute this, as you can see, we get this numpy array. Let me quickly take the random value here. Let's say something like 100. So the value of the class over here is 2. Let's do one thing. Let's create a dictionary or something. Or what we can do over here is we can see what is present in this data. So fashion MNIST. Anyways, so what I can do here is, so I have prediction over here, and this is giving the class 2. So let's see what does our xtest does. It's going to be y-test. So we have y-test, and let's see what does y-test give us. So we have 100. It should predict the same class, and as you can see, it's predicting the same class. So let's go down. Let's take some random number again, like 1000. So it should predict as the same class, so it's giving us 2. And now if I put down something like 500, so here now 500 should also give us 5. So as you can see here, now our model is performing fairly well. This is because, we have trained this using deep learning, and when we train model during deep learning, it tries to extract more features than what it would normally do. Now that we saw how TensorFlow can be used in deep learning, let's see its practical implementation and how it is being implemented by big tech companies. First off, we have voice or sound recognition. One of the most popular well-known use case of TensorFlow is sound-based application. With the proper data feed, neural networks are capable of understanding audio signals, and they perform tasks like voice recognition, voice search, sentiment analysis, voice-activated assistants. These are used in products like Apple Siri, Google's Android Assistant, and Microsoft Cortana. Further popular use case of TensorFlow is text-based applications such as sentiment analysis, threat detection, and fraud detection. Language detection is one of the most popular uses of text-based application. We all know Google Translate, which supports over 100 languages, translating it from one to other. The evolved version can be used in many cases. Next, we have text summarization. You see, Google also found one of the use cases for short text. Summarization can be used to learn with technique called as sequence-to-sequence learning. This can be used to produce headlines for news articles. Moving ahead to image recognition. This is mostly used by social media, telecom, and headset manufacturers. Face recognition, image search, motion detection, machine vision, and photo clustering can also be used in automation, aviation, and healthcare industry. Image recognition aims to recognize and identify people and objects in images as well as understanding the content and context. TensorFlow object recognition algorithm classifies and identifies arbitrary objects within larger images. This is usually used in engineering application to identify shapes for modeling purposes, and by social network for photo tagging up. Last but not least, we have time series. TensorFlow time series algorithms are used for analyzing time series data in order to extract meaningful statistics. They allow forecasting non-specific time periods in addition to generating alternative versions of time series. The most common use of time series is recommendation engine. You have probably heard of this use in Amazon, Google, Facebook, and Netflix, where they analyze customer activity and compare it to millions of other users to determine whether a customer might like a purchase or watch something. These recommendations are getting smarter every year. The other use of TensorFlow time series algorithm is mainly in the field of interest to finance, accounting, government, security, IoT with risk detection, and then finally we have enterprise and resource planning.